Perhaps the question of our ultimate origin is the most significant one we can ponder. Where do all these things come from? By examining the universe, we can find answers to many aspects of this question. Planets, stars, elements, atoms, and even the Big Bang stem from somewhere. However, the further we go back in time, the more we encounter an unavoidable dilemma. The universe cannot provide an answer beyond a certain point. The vast and ever-expanding universe is challenging to perceive as a complete entity. The circumstances of its creation are even more contentious. How can large galaxies with masses from hundreds of billions of stars suddenly emerge from nothingness? Despite numerous historical theories, humans cannot stop questioning themselves. How much do we know about the truth of the Big Bang Theory? Could it all be an illusion and the theories mere evidence of humanity's limited understanding? Science will continually evolve, which is why we invite you to join this journey to seek the origins of ourselves and the very universe we have always yearned to explore. Origin of the universe. Of all the questions we can conceive about the universe, perhaps the most significant one is asking right from the start, where does it come from? This is a challenging question, as to understand where something comes from, we first have to precisely know what it is. Similarly, we must have a thorough understanding of the laws of physics to calculate the outcome of a physical system starting from a specific set of initial conditions. Only from those starting points can we determine the feasible paths for everything to become as it is today and find out which path leads to predictions consistent with the universe we live in. However, it's noteworthy when examining this issue that regardless of when we pose this question in the past or future, applying a scientific approach to it will always yield the same cosmic narrative. Today, we have pushed remarkable boundaries in determining the origins of planets, stars, elements, atoms, and more. Under the development of contemporary science, the history of human theories about the universe has constantly evolved, portraying the universe as increasingly vast and mysterious. Studies on the universe date back to ancient times. In the golden age of ancient Greek civilization, there were two different perspectives on the universe, the geocentric and the heliocentric. The geocentric view considers the Earth as the center of the universe. The world was seen as a spherical object, immobile, with a transparent parent hollow sphere surrounding it. This hollow sphere was called the celestial sphere, within which the stars resided, moving around the Earth daily. Over time, with the scholarly contributions of Nicholas Copernicus, Johannes Kepler, Galileo Galilei, and Isaac Newton, there has been constructive development in our understanding of the universe. They are often referred to as the founders of modern astronomy. Copernicus supported the heliocentric view of the universe and redefined the solar system with the Sun at the center, around which all planets orbit. Kepler demonstrated that the orbit of each planet around the Sun is elliptical. Galileo also supported Copernicus' theory of a heliocentric solar system. Isaac Newton was the first to explain why planets move around the Sun. He is credited with conceptualizing gravitational force and formulating the law of universal gravitation. It states that every particle in the universe attracts every other particle with a force proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Adding another period, the Big Bang Theory emerged. The Big Bang is the most widely accepted explanation for how the universe began. According to this theory, the universe came into existence about 13.8 billion years ago. It started as a singular point known as the singularity. The singularity was an infinite mass with zero volume, hence it had infinite density. Consequently, the universe began as an infinitely hot and dense point. This singular point appeared from a vacuum for reasons yet unknown. In the Big Bang explosion, the singular point expanded and exploded violently, leading to the immense expansion of the universe. The expansion of the universe occurred rapidly in the first few seconds after the explosion. After a considerable amount of time, the expansion slowed down. It is believed that the first atoms formed within 3 minutes after the Big Bang event. Over the next 300,000 years, the temperature dropped to 4,500 K, giving rise to atomic matter, eventually becoming stars, planets, and more. The universe also became transparent to light. The universe has expanded from 13.8 billion years ago to its current form. Scientists believe that an undiscovered phenomenon called dark energy is causing the universe to expand. However, there is no specific scientific explanation for dark energy. Before the singularity appeared, no one knew what the universe was like at that time. The inflationary universe model is currently the best theory, assuming that the entire space was filled with extremely concentrated energy unstable and would transform into particles of matter at the time of the Big Bang. However, no one knows how space and time originally formed. The first rays of light. Today, with the advent of the James Webb Space Telescope, astrophysicists suggest that the best description of the universe's origin can be found through understanding the conditions present in the early universe, starting just a fraction of a second after the Big Bang. Studies on the cosmic microwave background, CMB, reveal that light preceded matter and even neutral particles. The CMB, remnants of the Big Bang, can still be found everywhere in the universe, forming the backdrop between galaxies visible to us. Such waves permeate everywhere, including Earth, where they can be detected. The European Space Agency's Planck Space Telescope, launched in 2009, extensively studied the CMB. As a result, ESA researchers discovered that the overall universal expansion rate is slightly slower than initially thought. The universe is also older than previously estimated, and our current understanding is that it is 13.78 billion years old. In 2013, researchers in the Planck project announced that they had found the earliest light formation mechanism immediately after the Big Bang. The universe was filled with subatomic particles, both matter and antimatter, colliding with each other at an equilibrium temperature of 2,700 degrees Celsius. Therefore, when a particle of antimatter collided with its opposite particle, both particles would annihilate. The current theory suggests that there were slightly more particles of matter than antimatter, explaining the absence of antimatter in the universe. Meanwhile, photons, protons, and electrons were colliding with each other. When protons and electrons encountered each other, they formed hydrogen, releasing light. This is how the first light in the universe was born, approximately 38,000 years after the Big Bang. Not long after, the universe underwent a period of rapid expansion. This stretched the wavelength of the initial light, turning it into a three-wavelength pattern, what we now call the cosmic microwave background, CMB. So what caused this hot dense soup of radiation and particles to spread out, giving rise to the phenomenon known as cosmic inflation? This is where things get a bit fuzzy. Something had to happen, an intense energy buildup stage, not caused by matter, antimatter, or radiation. Scientists believe this was a type of event involving extremely intense dark energy. As the expansion occurred, the universe flattened and cooled down. What we are left with is the universe we are familiar with today, with a consistent density, denser in some regions and less dense in others. As the hydrogen gas continued to accumulate, it formed a dense cloud that obscured all light. Over hundreds of millions of years, the universe evolved in complete darkness. Within it, the first stars, star clusters, and superstar clusters formed. A type of radiation called Lyman continuum was emitted from these stars, and in the subsequent billion years, this radiation reionized hydrogen, ultimately ending the Dark Ages and allowing light to travel freely once again. Researchers in the Hubble Space Telescope project have also provided profound insights into how the earliest light formed. Sunchari Barua from Johns Hopkins University, the lead author of a study, and her team conducted observations on a starburst first galaxy nearby, called J0826+4305. They aimed to understand how Lyman continuum radiation dissipated the fog enveloping this universe. J0826+4305 is a very small galaxy about 3 billion light-years away from the Milky Way. It is shrouded in a layer of dust clouds, causing it to give birth to a large number of stars. A star is born deep within the dense core of such a cloud, where temperatures can go as low as 262 degrees Celsius. These clouds have many holes due to the radiation emitted by the stars they conceal. According to Dr. Barua, this process reflects how the initial radiation burned off the hydrogen fog during the era of reionization. However, it also does not contribute to answering the question of the origin of matter in the universe. Does matter come from nothing? Contemporary science leads us to believe that the entire universe, essentially the laws of nature, emerged one day from nothing. This is a problem that scientists cannot address using the Big Bang theory alone. We know how matter and atomic particles came together after the big explosion, but where did that source of matter come from? How can a rational mind accept such a concept? We view physics as a kind of magic and do not question that over 14 billion years ago, more than 1,000 trillion tons of matter suddenly appeared. No theory adds certainty about the origin of nothingness. Today, as we look into the universe, all the observations we have gathered, even considering the uncertainties, point towards a remarkably consistent picture. Our universe is composed of matter, not antimatter, following the same laws of physics everywhere and at all times, and it began, at least as far as we know, with a hot Big Bang about 13.8 billion years ago. It is governed by the theory of general relativity, expanding, cooling, and gravitating, and it is dominated by dark energy, 68%, and dark matter, 27%, with normal matter, neutrinos, and radiation making up the rest. Certainly, today, it is replete with galaxies, stars, planets, heavy elements, and, at least in one location, intelligent life and advanced technology. These structures don't always emerge there by the evolution of the universe. In a remarkable scientific leap of the 20th century, scientists were able to reconstruct the timeline of our universe, going from an almost uniform, structurally simple universe consisting only of hydrogen and helium to the structurally rich universe that we observe today. If we were to start from today, we could reverse time and inquire about the origin of any structure or individual component of that structure. For every answer received, we could ask, okay, but where did that come from? And how did it arise? Until forced to answer, we don't know. At least, not yet. Then, finally, we can reflect on what we have and ask, how did it arise? And is there a way it could arise from the void? From the Big Bang to Sarah Palin is a vast distance. It would be wise to remember the experiments of Louis Pasteur, experiments that debunked the theory of spontaneous generation, the belief that life arises from non-living matter, e.g., maggots from rotting meat, mice from old clothes, and not fall into similar errors regarding the origin of the universe. We imagine time extending backward toward the Big Bang before life began in the primordial soup. However, experiments with real particles show that before matter can exist, it must be observed. Something must sustain it beyond non-existence and hold the world together amid change. That something is the mind of humans or animals. Generations past believed the world was a big ball sitting on a turtle's back, and now science makes us believe it's a miraculous universe emerging from nothingness and expanding into nothingness. We've traded a big ball on a turtle's back for a Big Bang. By reminding us of its tremendous success in uncovering the mechanisms of the physical world and crafting fantastic new devices from raw materials, science has freed us from the absurd explanations of the nature of the universe at large. If it didn't provide us with HD TV and George Foreman grills, it wouldn't command our respect long enough to draw 3 old cards when addressing these great issues. Just as Loren Eiseley once wrote, one does occasionally observe a tendency for the beginning. Zoological textbooks to take the unwary reader by a hop, skip, and jump from the little steaming pond into the lower world of life, with such shortness and rapidity that it is easy to assume that there is no mystery about this matter at all, or if there is, that it is a very little one. Science has sought to extend space and time beyond our appearance. Cosmologists have embraced the narrative of a molten Earth and traced it backward, through simpler forms of matter, to the Big Bang. However, physicists have learned that the world does not exist in a definite state independent of the observer. Tracing the origin of life through simpler stages is one thing, but assuming it arises naturally from non-living matter requires the precision of quantum theoretical rigor. In high school textbooks, we have seen peculiar devices like test tubes claim to simulate the primitive geological environment of the Earth and attempt to explain the origin of life in mechanical terms without referencing any observer. Although various types of organic molecules can be synthesized in many ways, and even in your bathtub, experiments would be incomplete without the inclusion of living organisms. Our interaction with molecules is crucial for their existence as tangible entities. Half of the experiment is that of scientists who may not realize that their consciousness can actually transform space into the reality of the spaceship. No invisible matrix explains our origin more precisely. For every living being, there is a universe of its own. According to biological theory, each of us creates our own realm of reality. We carry space and time around us like turtles with shells. The universe consists of billions of actual spheres, a mixture with a vast range. It's noteworthy that anything you do not directly observe exists only as potential or, more mathematically put, as a cloud of probability. John Wheeler, a great physicist, once said, "Nothing exists until it is observed." Because time does not exist at any level before observers, traditional explanations of the universe before Earth cannot account for our origin. Think of the universe like one of those globes you see in the classroom. It's simply a tool representing everything that can be theoretically experienced. But, like a CD, the music only becomes reality when you play one of the songs. Instead of the universe having an absolute beginning, imagine its existence as a record depending on where the needle is placed. You'll hear a specific song. This is the present. The music before and after is the past and the future. All the songs exist simultaneously, even though we only experience them one piece at a time. What do we